Next method would be the Newton-Raphson method. Okay, Newton-Raphson. What is the difference between Newton-Raphson? Okay, in fixed point iteration, we we rearrange the equation from the given function, okay, to get the x. But for Newton-Raphson, okay, Newton-Raphson assumption is when you are given one point, this is your given point, okay, xi or xn, to find the new x, okay, the new x new, this one is x whole, okay, or sometimes xi plus 1. Okay, don't get confused with the subscript. Now, this is the initial point. To find the new point, Newton-Raphson assumption is by using the Fn and then project the slope of this point. You see this, the slope of this point. So this is the new point. Okay, using the slope of the old point. So to find the slope, m delta y over delta x, correct? The slope, okay? Where this function is equivalent to differentiation, right? Which is y, sorry, wait. I use the same term. I don't want you to get confused. Okay, here, it used the term fxn. Fxn here means the y value for this. Okay, the y value. Now, the slope here, delta y over delta x, equivalent to differentiation of the fx. Differentiation. Delta y over delta x. That one is from the graph. But for differentiation analytically, you need to do the differentiation. Okay, so this is when this equation comes. To find the new point is equal to the old point, okay, xi, the old point, minus fx, the given function, and the differentiation of the function. Okay, fx over here is the fn over the slope, so that it will direct you to the new point. Okay. Now we try this. We discuss this example so that you can understand further. Now this example asks you to locate the root using this equation. Starting point 0.5. Perform computation until EA is less than 0.5. In your slide, perhaps 0.01. Correct it to be 0.5. Because I just want to keep the calculation short. If ES 0.01, you will have a lot of iteration. Okay, just to keep it short, we use ES 0.5. Now, we know that Newton-Raphson method to find the xi plus 1, the x new, is equivalent to the xi minus fx over f prime x, the differentiation. Okay. So using your starting point, which is 0.5, now we want to find the x1 over here. So x1, 0.5 minus fx. Fx is the one that is provided to you, the function. Okay, so you plug in into this fx. Okay, 0.5 minus 0.5. 0.5 minus 0.5 You substitute the x value to 0.5. Okay, the one that I want to focus here is the differentiation, the lower part here. So this one, you need to do it analytically, differentiate it from this fx function, so differentiate it. Now, what is the differentiation of this equation? What is the differentiation of that equation? The f prime x, what is it? Sorry? This, right? Okay, you do the differentiation of this function. Okay, then substitute into the calculation the differentiation function. Okay, substitute the x over here. Then you will get your x1, this value. Do you get the correct value for 1? Okay, now try to proceed until you get EA lesser than 0.5. The first EA over here, why it has values? Because it used the starting point, the x0. So here is x1 minus x0 over x1. Multiply 100. That's how it gets the EA. Okay, try to proceed. Let me know until how many iterations for your xi to be below 0.5%. Anyone need me to repeat? I repeat. Okay. Newton-Raphson, the assumption is the new point is directed by the differentiation, the slope of the point. Okay, as I mentioned just now. Here is your first point, x0. So the next point will be directed by the slope. This is your xi plus 1. Okay, so to get this slope is by calculating the m delta y over delta x, which is this one is equivalent to differentiation of the function. Okay, dx over dy over dx, it is differentiation. So to find the differentiation over here, by using the function given, so you differentiate it analytically. From here, differentiate, you will get this one. Okay, now substitute all the numbers of x 0.5 into the equation. Then you will get your x1 as in the slide. Okay, for iteration number 2, your xi will be x1 number, x1 figure. Use back to the xi. Then you get x2. X2, you'll get somewhere this figure. EA is reducing. Okay, to find your x3, use your x2 number. Use your x2 to get your x3. How many iteration you get? 500. Where's the root? Yes, correct. Until fifth iteration, the x is negative 0.9712 with 0.2%. Okay. Yeah, this one, the equation is quite simple, quadratic. Let's say the equation is involving the sine cos. Example 2. It's theta. I want to draw theta here. Okay, here it has concentration of a product, theta, signed by theta, follows this equation. It asks you to find the value of theta with initial gas of 0.8 using Newton-Raphson method. Okay, so this is your fx, the sine theta minus theta power 2. We know that the Newton-Raphson required the differentiation of the function. Okay. Now, Newton-Raphson method to find the xi plus 1 using this equation. Okay, your fx is this, sine theta minus theta power 2. So your f prime x, what is it? Differentiation of the sine. Cos. So you will get cos theta 2 theta. Okay, then proceed with your iteration. Start with xi 0.8. That one is 0th iteration. Okay, the given starting point. So the first iteration using the Newton-Raphson method equation to find your new point. Remember to use radian mode. Okay, when it involves sine cos theta, sine cos the triangle, use radian mode. Okay, I give you the hint. X1 will be 0.8856 with EA of 9.66%. Stop at iteration 4. Because here it doesn't give you the stopping criterion. Try to maintain your X figure to 5 significant figures. The rest should be done because I uploaded the recorded lecture in BCN. So if you miss the class, just watch the Okay, can get Aisha? Naresh? Tasmia? Got it? Rabia? Get it? Okay. Okay, so Newton-Raphson has its own pitfall, meaning that the limitation and the disadvantage. Let me make it bigger. Okay, we know that Newton-Raphson, to find the new point is according to the slope of the point. Okay, let's see here. This is the starting point. Okay, then this will be the fx. Right, so from the slope here, it will direct the x1 to this point. Okay, so fx1 will be the one that touching the line, the equation. This is your fx1. To find the x2 point using the fx1 and also the slope, you'll get to this. Okay, so you see the trend from here after x2, it is going somewhere else, diverging from the root, whereby it should be converging to the root, right? Okay, so this is the pitfall of Newton-Raphson because it depends to the slope of the point. Okay, and then it depends to your starting point and also the function. In this case, certain types of function will bring out the divergent trends. Okay, this one, this example, this is the starting point. The slope is pointing to this part. Sorry, this is the fx. Okay, so you see the point randomly, not approaching the root over here. Should be approaching the root. This is your XR, the one that you need to find out. Okay, same goes to this. The slope pointing to this, then this slope pointing to here, whereby this is your roots. Okay, so it depends the slope of the point for Newton-Raphson. Now, it has few limitations. In this slide, we have three, stated here three. Number 1, number 2, and number 3. Okay, now I want you to find out what is the explanation behind this limitation. Okay, I want you to find out why, then explain to me next class. Okay, so I'm giving this as your part. Try to find out what does it mean by limitation number 1, 2, and 3. Okay, I don't want the only one sharing the knowledge over here. You try to find out, then you share the knowledge with the rest of the friends. Okay. Now, this limitation, I leave it to you. I'll proceed to the secant method. Basically, secant method approach is quite similar to the Newton-Raphson. Okay, Newton-Raphson just now, the slope, not so clear. Sorry. Okay, in Newton-Raphson, just now, to find the xi plus 1 is equal to xi minus fx over the differentiation of the function, right? Where you need to do the differentiation analytically. Okay, secant method, the assumption is evaluation of the derivative for the Newton-Raphson, the differentiation part. If you are given a complicated equation, a complex equation, so it will be quite hard for you to derive it, to differentiate it. Okay. Extremely difficult or inconvenient to evaluate, to do it analytically for the differentiation part. Secant method comes in by the assumption that the fx part over here, we know it is delta y over delta x, right? Okay, so that this is your starting point. This is your fx. Okay, secant comes in is by dealing with the slope equation, where here to find the slope, it used another point. To find the slope over here. Okay, just now the slope is equivalent to the differentiation of the function. So you analytically differentiate it. But now it used the slope equation to have the y2 minus y1 over x2 minus x1. So here you only have 1 point, Newton-Raphson. To use this equation, you need extra 1 point. So it gives you another point in order for you to find the slope. So this one is equivalent to the fx as well, f prime x as well, right? Now the slope still pointing to the new point. The approach is it deals with the slope equation, not analytically differentiate the equation. Okay, so here, this is the equation, the y2 minus y1, x2 minus x1 to find the slope, which equals to f prime x. Okay, so substituting this equation into the Newton-Raphson equation. Okay, this one is the Newton-Raphson equation. Okay, so substituting this equation into the Newton-Raphson equation, it will brings you to this secant method equation. Okay, this is the rearrangement of the substitution part. So this is the final secant method equation to find the new point. Okay. Anyone need me to repeat? 2 minutes for you to digest. Okay. So for the second method, you will need two starting point, two initial, xn minus 1. Okay, xi minus 1. So you will get x1 over here. Now, how to find x2? Now you obtain the x1 from the two starting point over here. Again, why you need 2? Because you need to find the slope, the gradient. Okay. Then it will direct to your x1. To find your x2, so using your x1, this is 1 point. The second point, which one will be the second point? Xi or xi minus 1? Huh? Xi. Xi will be your second point. This here. So you will need to calculate the slope at this point, which will direct you to x2 point. Okay, that's how you do the iteration using the previous two value. Okay, now we proceed with the example using secant method. Locate the root for this function. Okay, you see the function is quite complex. So if you want to differentiate it analytically, it will take some time. It gives you the starting point of this, xi minus 1, xi2, with es 0.5. In the lecture slide, it doesn't give you the es, so you just add in. Okay, let this one be, this one is xi minus 1, xi. Then another column will be your EA. Okay, so we start with the first 2 points. Xi minus 1 will be 1, xi is 2. Wait, this one not EA. This one should be your xi plus 1. Then only the EA. Okay, now using the secant method equation, where you need to use to find the xi plus 1, xi minus fxi, xi minus 1. minus xi from the equation just now. Okay, so xi here referring to 2. So fxi, you need to substitute 2 into this equation. If xi minus 1, so substitute the xi minus 1 into the fx equation. Okay, try it. Not enough space. So you must put the correct equation. Sin x plus cos this thing minus 1. Okay, don't leave out the minus 1 over here. I don't have enough space over here. So plug in the equation given. The xi plus 1 for the first iteration, you will get 1.7486. No EA. Okay, it should has EA already. Okay, for the next iteration, let me explain first. For the next iteration, you need to decide which one belongs to I minus 1, xi, and which one that you need to find. Now, this xi plus 1, when moved to second iteration, it will move to xi or xi minus 1. Xi. Xi move to xi minus 1. Okay, because why? Because first thing we need, this is your xi, I minus 1 to find the xi, xi1. Okay, so using the slope, you need to find the x2. To find this x2, you need 2 more points. So that's why the xi over here will form xi negative 1. Now later on, the xi plus 1 for second iteration will move to the xi. So this one will move to xi minus 1. You get the EA correct? Okay, for the first iteration, how do I get 14.38 is by using xi plus 1 minus xi. This is the previous value. Xi is your current. This xi plus 1 is current. This one is previous. Yeah, xi is the new value that you calculated from the previous value. So that's why the first iteration, we can get this EA. Until third iteration, the EA is already lesser than 0.5. Okay, any problem? Easy. It involves a lot of calculation. It's just the method that you use. Okay. So we are done with 2B, root, open method for root. We have covered the bracket method, the close and open method. Actually, I want you to do this exercise, but we are running out of time. It will involve a lot of calculation over here. This one from final exam May 2022. This one we proceed tomorrow. We will do together, not only for secant method, we will try for Newton-Raphson method as well. Okay, so this one tomorrow we do it. After that, after we are done with this exercise tomorrow, I will proceed to chapter 3, which is the linear algebraic, the matrix part. Okay. Okay, so that's all for today. Thank you.